Welcome at isdaT for this first event of the project for you. So today we will have Jean-Luc Maté that will talk about a subject about automobile. So for you is a project funded by Europe between Barcelona and Tolosa. It involves cities, company, university and institute. And in this project, the goal is to develop the mobility of the future and to involve students from different schools in Barcelona and Toulouse. And we have different phases in this project. The first one is about ideation, in which we will have some different seminary in Toulouse and Barcelona on different subjects around the mobility of the future. Then in a second phase, we will try to develop some ideas and make some prototype with a student. And then in a final event, we will make a vote with industrial people, and some of solutions will be selected and will be implemented in a city, in Toulouse and Barcelona. So it's a long project during 1 year, in which we will have different events, and you can follow us on the website of 4i4u, in which you have done the registration for this event. So today we have Jean-Luc Maté. He's a guy that are working in industry and automotive during 40 years. He worked in different companies, Bendix, Continental, have some other, Siemens, and he worked on different subjects around automotive, on ADAS, on cockpit, and mobility as a service now. So you have a great knowledge about automotive, and he follows this industry in different way as a representative of automotive at a local and national organism. And today he will talk about Draw Me an Urban Car for the Future. So I let you the floor. Thank you.
Thank you, Thierry. It's a great pleasure for me to be with you today. I don't see Barcelona, but I would like to say bon dia, Barcelona. The talk will be in English, so my Scottish accent from Toulouse should be very easy for you to understand. So, Le Petit Prince asked me to draw an urban car of the future, but this will be you that will design it. I will give the recipe, and it will be your task, as Thierry explained. So let's talk about rapidly the evolution of transport and the genesis of automobile in the world. 6,000 years using horse. 6,000 years using horse. This is a statement that perhaps we don't have in mind. When we are talking about horse, minus 4,000 years before Christ, until 1920, and 1920 was not really ending date. In some area, it will be longer. So we are talking about 6,000 years of using horse, and just a small part of 100 speaking about something different. Here I put a photo of the 19th year in Barcelona and in Toulouse, and you see on the street horse everywhere. That's clear. All cities at that time were using horse for transport and for mobility. The first time there was something different without any horse to handle mobility was in 1768, when Nicolas Joseph Cugnot tried to use steam as an engine provider. We call steam external combustion engine, and this will not stop immediately, but if you look carefully to the story, in 1885 there was really a big industry started by Monsieur Dion Bouton that was developing a lot of different cars with using what is called external combustion engine, using oil for lighting lamp to heat water. So when you have to fill this type of car, you need water and oil. And you see in 1908, this car called White Touring is still using steam. So you see that steam has been used as an energy during a long time. came a new word in 1890. The word called automobile is a very European root-based name coming from the Greek auto, that means oneself, and the Latin mobilis, that means mobile. Self-mobility, self-mobile. Horse has to be replaced by something else, by an energy on board. The question is, which energy? Big event. 1887, Mr. Carl Benz developed the first internal combustion engine, what we call the thermal engine. And a colleague not too far from him, Mr. Otto, developed the diesel version 1. So gas and petrol was capable to be used as energy. At the same time, remember that in the 19th year, in Paris, there was a universal exposition. And during this universal exposition, everything was electrical. Everything was electrical. The magic of electricity was everywhere. And clearly, with electrical machine, the DC current electrical machine, invented some years before, a lot of cars driven by lead-acid battery was developed everywhere. In UK, in France, in Germany, and in the United States also. Look to this picture. This picture demonstrates that in the year 19, it has been quite difficult to select the winner in terms of energy. Which energy will be used in the future? If you look to the number of new cars in the 19th in the United States, you see 1,681 was using already steam. That means water and lamp, petrol lamp. But 1,565, which is quite the same number, electrical. That means the electrical car was really very important. And gasoline, that means the gasoline car using the internal combustion engine was just using 900 cars. So you see that at that time and during some years, during 20 years, there was a big battle between the one that was supporting electricity and the one that was supporting the gasoline. At the end, there was a big event that changed the world, completely changed the world. In 1908, Mr. Ford invented a concept to generate the electrical car killer. The electrical car killer is the industrialization, the massive industrialization in factories, fully automatized with a lot of people working simultaneously to assemble cars in the same place. That means at the end, the cost of this car are 50% less than any other. They have 100% more range possible with just filling the tank of the car, and it's so easy to fill with gas pump, very easy to fill. So Mr. Ford has been the killer of the electrical car forever, in 1908. And the same came across Europe and everywhere. So I think it's interesting, as today we are talking about energy transition. We are questioning about the energy. What do we have to do? Is it electricity? Is it new biofuel? Is it biodiesel? What do we need to use? Is it hydrogen? We have the same type of competition, and you look, it's just 110 years before. So 110 years is 1 minute in the 6,000 years of using horse. Let's have a look on what we call the urban vehicle focus. Look to the traffic jam in 1930. 1930, Paris and London was crowded of cars. Look to all these cars. Those cars are large, heavy, long, take a lot of place on the street. So a lot of traffic jam was occurring at that time in Paris and London. You can see, especially on the London side, where they are driving on the other side of the street, that there are still some, in 1930s, there are still some horse carriage running on the same street like automobile. So, what is the urban vehicle requirement? It has to be lightweight, small size, having a small footprint, not taking a lot of place for parking it. Low speed. The speed in the city is limited to 50 kilometers per hour. Low price. It has to be affordable by the majority of people. And low consumption. It has to have a low consumption. Low consumption arrives naturally with lightweight and low speed. This is something that is helping a lot. 1916, look to this first urban vehicle. What is this? It is called, in French, trottinette. It is called a scooter, electrically assisted or petrol assist scooter. You see this lady on the 1916 in New York, 5th Avenue, running with this vehicle. And if you go later in 1953, a very popular way to transform a bike to a motorized bike. This was the invention of what we call the Solex, Velo Solex, that has been something very popular because it was consuming very few gasoline, 1 liter per 100 kilometers, and it was very easy to use and to transport. And I think this has been the starting point of bringing mobility to the maximum of people. We can see later that will appear in the same approach in China. So, after the COVID pandemic, that people are afraid to take bus and metro, public transport go down, and micro-mobility go up. Let's imagine that there was in France people buying bikes and scooters by hundreds of thousands. We are talking about 2020, 900,000 scooters and the same amount of bike. So micro-mobility in urban city rise up dramatically. If you look to this picture, you see that a car weighs 1,200 kilograms to transport one person of 60 kilograms. There is something that is definitively not fitting with the expectation of energy spending. So, of course, if you take a bike of 20 kilo or a scooter of just 15, the ratio between what you have to transport and the way to do it is more in accordance. 1942. We are on the Second War, in the middle of the Second War. We are in Paris, and a designer, Mr. Paul Arzin, generate at that time the first urban car concept, which has been called the electrical egg. Let's try to see this car running in Paris.
Le peintre et sculpteur Paul Arzins, s'inspirant de la résistance et de la forme aérodynamique de l'œuf, a conçu une étonnante petite voiture électrique. Cet engin, appelé l'œuf électrique, et que l'artiste a construit lui-même dans son atelier de Montparnasse, a un rayon d'action de 150 km et atteint la vitesse de 75 km à l'heure.
Now it's like how to come back to my presentation. So you see that all the requirements were fitting here, and in addition, in France during war, there was no easy way to find petrol. So this is a tendency that this car has been used after war and realigned, and Mr. Arzin drive it until his death in 1968. just after war, we need to bring mobility to everybody. Cars have to be simple and have to be affordable. If you look to the car that was the launch on the market in the Salon de l'Automobile in Paris, you see 4 chevaux from Renault in 1946 and in 1948, 2 chevaux Citroën. Light car, for someone very small and easy to run and not so expensive compared to the salary of people at that stage. In 1950, in Barcelona, as we are talking also to our colleague of Barcelona, came the Seat 600. Look, this Seat 600. And in 1957, in Italy, Fiat developed, after the Pandolino that was developed during war, the new version called Fiat 500. And all these cars are exactly fitting with the requirement of what is an urban car. And you see the shape of the egg is still, I would like to say, the main basic design that is here. So, in 1955, a company named BMW, Bayerische Motorwerke. This company was in the past designing, manufacturing engine for aircraft and want to enter in the business of automotive and automobile. He go to Italy and find this design from a designer, Italian designer, and he say, wow, I will do it. I will industrialize this car for my colleague in Munich. This car named iZeta, the name you see is an Italian one, was measuring 2.28 meters, having a weight of 350 kilograms, and capable to transport 3 people. This is, and this is BMW. The same year, you should understand that the same year in France, in 1955, Citroën launched the premium limousine DS, and BMW iZeta. You see how life is changing across time, 40 and 50, 60 years after, things are changing. This is now a startup in Switzerland called Micro that redesign again the iZeta with modern technology in order to bring again this car to the car sharing market for cities. You see, the weight is more important because this car is using battery, is an electrical one, and also the price is different. As the inventor of the electronic watch, the boss of Swatch, has the idea to develop a microcar for cities. And he tried to do the Swatch Mobile in 1990 and failed. At the end, he made a joint venture and a cooperation with Mercedes to create Smart. And in 1998, Smart 42 became a popular car. Thanks to this car, Mercedes developed, especially in Germany, the car sharing, and today is also pushing this in different countries. We talk, if you look to the world and go to India, Indian people are a country where what we call jugaad, frugal innovation, is something that is everywhere, doing more, better for the consumer with less. The high value for low cost in mass volume is something that you can find everywhere in India. For that reason, all car makers that are doing premium cars are in India. Renault is in India. Fiat is in India. Everybody is in India because in India you learn how to manage mobility in an affordable manner. One company in Italy is particularly present in India. Gruppo Piaggio, Vespa, the inventor of the Vespa, the famous Vespa. The famous Vespa became an urban car. You see here a lot of versions of this car that was developed in the vision of bringing, like in India, more for less. You see, this is an ultra-light car. It is just a scooter with some body finishing in order to make the car with different purpose. 1 year ago, Piaggio Vespa launched this marvelous small one car here, and you can see on the top, to attack the Indian market and the Vietnam market. This is also a Vespa, but designed and using a body à la mode with, I would like to say, some feature that will please people. And when you see how people are transporting today in India, you can understand. Renault tried with Twizy to make it. It was a failure. The car was not fitting with this car was okay for California, seaside, but not for being drive without window in a city. It does not really develop. So Renault developed a new version this year called Mobilize, this one, and this version, which is an electrical one, Twizy was an electrical one also, has a purpose to be a car sharing. That means that this car will be on the road, and with your smartphone, you can take it like a bike, on demand. In France and in Italy, we have been very creative, I would like to say, sometimes, like the Indian people. We invent a category of cars that do not exist in this manner in any other country. It is called light quadricycle, which does not need a driver license to be pilot. It is called light quadricycle. All the companies you see, Ligier, Microcar, Châtenay, Exam, all these companies are French, and they sell a lot of this sans permis driverless car. Casalino in Italia and Piaggio do the same. And this market was a market of 20,000 new cars per year. A newcomer came 2 years ago called Citroën. Citroën, with this Ami car, which can be rented at Fnac Darty, is really, typically, if you look carefully to the shape, the urban typical car, electrical, less than 420 kilograms, can run maximum 45 kilometers, and capable to have an autonomy of 70 kilometers in an urban city. So something that is capable to move, and this type of car is developed also by Peugeot Group to be installed as a car sharing in cities with special application. Americans in the Massachusetts Institute of Technology try to reinvent again the urban car in their lab. And they found that even if the car is small, if you make the car standing up, you can park more car. You can park 2 times the number of car instead of having the car flat on the street. And this car has been interesting General Motors in the States, and General Motors is working on making this as what we call autonomous pod car. The idea is to be transported from a parking to public transport without thinking, without searching for your way. You go down from the metro and you go to your parking with this autonomous pod for 2 persons. This concept is under development. China. We cannot escape from speaking about China. Why? Because China is #1 market in the world today. When I was young, there was America, Europe, and Japan. Today, there is China, Europe, America, and Japan. This market is huge. The market starts with people that make a lot of money with startup and buy Audi, Mercedes, BMW, luxury car to demonstrate their fortune. Step by step, there was new car maker coming, and there is today in China more than 50 car makers that are developing cars. But the question was to also bring cars to the maximum of people. In China, you have bike, electrical assisted bike, you have scooter, electrical scooter, and if you want to bring your family with a son, a daughter, your wife, to go back home, it's quite dangerous and difficult. And if you go to shopping in the supermarket, it's more difficult. So, a joint venture between a SAIC car maker and GM developed a new small car. It is typically a city, an urban car. It was a fantastic development. They sell the first year 424,000 cars. Can you imagine? 500,000 cars sold in 1 year. 500,000 cars. The price is €3,007 equivalent. And it's a tremendous development. I'm sure that this car will come to Europe soon because General Motors is beside, because they are importers. So this car is a city car. It's a city car. But it's not a quadricycle. It's not a light quadricycle. It can run 100 kilometers. There is an electrical car. It has a minimum number of battery because if you are running on city, you don't need to drive long. So it's a small urban car. I will talk now about things which are a little more complicated. I apologize, but that's reality. In a modern car, you have more than 100 functions. What is a function? Drive an engine, pilot energy, brake, do an emergency braking, have navigation. You have more than 100 functions. These 100 functions are software encapsulated in control unit. The organization of the vehicle is made in such a manner that all functions are integrated in control electronic system, and these control electronic systems are clustered in domain: powertrain, engine, body and comfort, interior, chassis, steering, braking, suspension, and infotainment, navigation, radio, application, connection to the smartphone. These are the foundation of this electronic architecture. Very complicated. A lot of database exchanging information and inter-system information between domains and between ECU, and recently, something that was not expected enter in the car, Ethernet. Ethernet backbone is today on many cars in order to make the things running accordingly. So we say a car is a smartphone on wheel. We are talking about how many cars? In the bad years, that means the COVID one, 80 million new cars per year. 80 million. 80 million cars on Earth. 15 control electronics in a small car, 70 control electronics in a premium car, averaged 35 control units per car. The electronic control unit is made with a lot of chips, semiconductor, microprocessor, very sophisticated. And if you calculate the number of electronic control modules that have to be produced per year on Earth, 80 million multiplied by 35 ECU average per car means 2.8 billion of electronic modules have to be produced per year to control cars. Look to the number of smartphones, all brands that have been supplied in 2021, 1.3 billion. So when you look to the TV set and you say, oh, we have a problem of shortage of semiconductor. We have a problem because we don't have sufficient amount of chips to manufacture cars. This is a problem. And if you add electricity on car with electrical motors, with power electronics, an additional control module to control the power of the electrical motor, you multiply by 1.3 the demand of chips and semiconductor. Software tsunami. I put this name because it's really the reality. The reality is on the car today, there is an increasingly strong development of software. The software technology is becoming the mandatory technology. I put 3 announcements that was made last month by Volkswagen. Volkswagen say, I need 10,000 software engineers to develop my cars. Mr. Carlos Tavares at the group Stellantis, Peugeot, Chrysler, Fiat say, I need the same amount of engineers for software. And Renault say, I need a software factory in Europe, in France, in India, and in the United States to be able to develop the software of the future. So, plus 100 million line of code for a premium car. We are far from doing a car in Montparnasse, in a design art studio. Metal has been changing to copper and semiconductor, to silicon. The product, even if it is a small urban car, with electrical motors, with batteries and connectivity, is complex. There is a need of plenty of engineers. Please keep in mind that the research and development of automobile in Europe is the #1 sector of spending research and development. 57 billion euros of research and development is the automotive sector. If you take aeronautic and defense, is 1/10 of this. So #1 sector in spending research and development, it's automotive. And if you add new energy on the top of it, new infrastructure and new mobility services, it's more. Okay, look to these curves and be proud to be European. You are European, I am European, I am proud. I am #1 in the world in achieving the minimum number of grams of CO2 per kilometer. Look to my colleagues in the United States, look to the other people, even China changed its mind by developing actively their technology in order to go down rapidly by importing European technology to China in order to go down. So #1 in the world in less polluting with cars is Europe. But Europe is always willing to be more than more. 14th of July, last year, Europe say, hey guy, I need more. And they asked to the industry, the European industry, to go to zero by 2035, which is a big change, big change. This is not something that is written and filmed, but the question is, can we do it? People are working. Like it was working in the 19th, people are working. Third generation of biofuel with algae from sea. New generator of high temperature electrolyzer to generate efficiently hydrogen. New generation of solid state battery. Plenty of people are working around the world in order to improve the functionality of each of those technologies. There are 4 pillars. The first one is, I can use biofuel, biogas. The second line is, I will use hydrogen in the thermal engine, replacing gasoline and diesel. Third line is, I will generate electricity with hydrogen and fuel cell. And the last one is battery. If you look to this picture, I don't want to enter in details, but what is, you see black figures, green figures, you see blue light figures and green figures. There is no one winner. No, there is no one winner. People are working, they are trying to improve. So, when European Commission say no more thermal engine by 2035, I ask the question, and if we found a good way to put hydrogen in thermal engine, if we found a fantastic new biofuel or biogas with algae, if we improve this element, will it be still stupid to cancel completely the thermal engine. So the question is on the scientist hand. The political people are trying to push some direction, but we need to be careful, and we need to understand. What I would like that after this presentation, your brain will be educated to not listen and say, oh, just listen and try to understand. I put here a use case, which is a comparison of an electrical car on the top and a gasoline one here. And the question is, how much CO2 emission are we generating when we manufacture a new car? If it is an electrical one and if it is a gasoline one, the main difference is the electrical one has a huge battery. 300 to 600 kilograms of battery is necessary to handle a modern electrical car with a range of 400 to 500 kilometers. So the question is, if I take the Chinese car, 100 kilograms of battery, I will divide by 6 the CO2 emitted by the battery construction. Think about it. If I am a Tesla boy and I want to push 600 kilometers of autonomy, I have a 600 kilogram battery. I double the figures in terms of how much I will consume CO2. I have to extract cobalt, nickel, lithium ion, and a lot of other elements to manufacture those batteries. I have to find them, I have to import them, put on boats, come to the factory. A lot of energy has to be spent to manufacture this. Look to this picture, very interesting picture. This picture, you should like this picture and you should look at it each day, and each year you have to measure the progress. What is black? Black is the generation of electricity in each country. Each country generates electricity. Some countries generate electricity with fossil energy. Some countries generate electricity with renewable energy. Wind, solar, geothermal, hydroelectric, nuclear. If you look to this, you see that if you are in Poland, you are not in a good position to use electricity to drive a car because you are generating so much CO2 per kilowatt. If you are in Norway, zero emission. If you are in Sweden, close to zero. If you are in France, here, you can promote electrical car. Of course, our electricity is green. Look to the next figures. How much CO2 emission to produce the fuel? So if you calculate 150,000 kilometers of life duration for each car, you need to recharge your car with electricity. If you recharge your car with electricity, that is black electricity, you generate 23 tons of CO2 during the life of the car. If you use gasoline with an engine that is at that stage 2014 generation, you are generating 6 tons. No, excuse me. You are extracting gasoline, and this generates 6 tons of CO2. And when the car is driving, clearly an electrical car do not generate CO2. A gasoline car will generate. But which type of car are we talking here? A car of 2021? No, this was a car of 2014 with a gasoline consumption of 6 to 7 liters per 100 kilometers. That generate 17 tons of CO2. If you have a 95 grams car, you generate 30% less. And if you improve the efficiency, less and less. And if you use biofuel, less and less. So I will encourage you, when you have comparison, to have a careful look on what we are talking about, which technology, how the design has been made. If it is an urban city car, you don't need a large battery. If you don't need a large battery, of course, I am in favor of going in this direction because this direction is very interesting in terms of generation of CO2, even from the starting of the vehicle entry on the market. If you are having a very large car or a heavy truck, don't use battery. You will consume too much of CO2. Circular economy. Recycling. What does that mean? That means that I stop mining, continuously digging on the earth to extract materials, metals. I reuse. Give me your whole car, and I extract the metal and the elements. Give me your battery. This is a schematic made by Renault 2 months ago to demonstrate what he calls the concept of three life battery. The battery has the first life, a second life, and the third life is the recycling in order to re-enter material in the factory to refactory again battery. So I think all car makers understand that if they want to decrease their CO2 emission during manufacturing of the car, they should recycle metals everywhere. Recycling, repairing, retrofitting. The car has to have long duration. And you have to retrofit and update the technology in order that the car is always generating less CO2. Let's talk about another element that changed the world of urban car and of mobility. Mobile phone. You are all of you young, so you don't remember when mobile phone was coming in the market. There was a time where there was no mobile phone, only fixed phone. And came mobile phone. And mobile phone, first generation, was not too good. It was an analog type of mobile phone. They called mobile phone GSM G1. First generation, not too good. As soon as came the generation 2, it was possible to use it in a digital manner and send digital SMS. So what I can do, the people have the idea to say, I will extract data from the car, I will bring the data to the cellular phone, and the data will be sent by the cellular phone in SMS to the public operator. And the public operator will send the data back to the service provider. And here I put the screen, this is a screen in the United States of a lady that is taking care about a fleet of cars in the United States. Perhaps it's a car in the, I don't know, in the Colorado, in the Texas, and this car has an accident. It's a red alert. And immediately this lady received an SMS. Emergency. First step. Second step, the magic of GPS. You cannot imagine what was a big change for us when came GPS, global positioning system. All these satellites flowing across the earth and bringing information to geolocalize. It was primarily a military constellation sent by the US. And one day there was a big accident of an aircraft, and the President of the United States said, oof, we need to bring GPS to the civil and to the public, to the aircraft company and to everybody. And step by step, the military GPS became a civil GPS. At that time, look, the navigation. The first navigation was like this. It was an autoradio and a small screen indicating turn, 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 if you want to turn, if you want to go to a place. So there was a turn-by-turn navigation on the small screen. Came TomTom that deliver a device in color, fantastic. And TomTom have a very short duration because navigation is software. And in the software industry, there is open source. And open source navigation software came to everybody. And you can put it on a smartphone, and came an application. And if it is an application on the smartphone, there is no more business, at least for the selling people of navigation device. But the business is for others. The business is called location-based services. What is location-based services? If you put on a car a small box with a cellular phone and a GPS. The GPS knows where you are. The cellular phone can send information to someone. And the someone can be a service operator. The first one, as I show you, was General Motors. In 1996, create Onstar Service. And you see what was the Onstar Service? Stolen vehicle assistance, automatic crash response, emergency services. You can imagine that in the United States, there are typhoons, there are fires, there are earthquakes, a lot of things that are dangerous. So people in the United States were very happy to have a service for rescue and for a companion to support. In Europe, the service was developed by insurance, pay as you drive. The same, the insurance company know how much time you drive, what is the speed you drive, are you driving during night, are you driving in special areas where there is a lot of accident usually. All this type of thing generate, modulate the price of your insurance contract. This was very popular in UK and in Italy and developed after by all insurance companies. And the third one that was a big business was the fleet management. Fleet management is a fleet of taxi, of delivery, of logistics, of everything that is organized in a fleet was managed by a tracking system, making the link between your car, your truck, and a service operator. This generates the world of telematics. Do you know this word? Telematics is a French word, invented by French again. Télématique. Télématique is téléphone plus informatique. It became a worldwide spelling of telematics. Telematics is how to use the data which is in the car, how to use the location of your car in the city and generate any kind of service. What is new? This chart has been made by myself 20 years ago. With colleagues, there was a worldwide organization of innovation within the group I was working for, Siemens, and we worked during 1 year to collect all use cases everywhere, in all countries. And we put all these use cases here on this chart. And when you look to this chart, you see that there are use cases between car and infrastructure. That means that the city is talking to the car to car. Cars are talking each other. At that time, this was not existing. Now it will come. If you follow the conference on the 5G communication, you will understand what does mean cooperative communication between cars. Cars will speak to each other without saying anything to you. They will speak. They say, the car say, I will arrive in a cross border here. Take care. Or there is a red light that is coming. So the car will call to each other. Why? To prevent accident. What is important is zero accident. What is important is zero traffic jam. What is important is zero emission. Keep in mind that this industry will not survive if they don't find great ideas to manage these three ingredients: zero emission, zero accident, and always connected. So, and the last one is a device, is connect with the device. Why? Because if there is a working man on the road, you have to detect it. You have to detect it. And this is a way to do it with car-to-car communication. Car makers are dreaming to become service provider. Why? Today, car makers are selling 50% of their car to professionals and 50% of their car to public, to you. So they want to really stay a major player in the world. To stay a major player in the world, they have to be something more than just selling a car. They have to sell mobility services. I bring this chart because I think this chart is the most complete that you can find today. All car makers have activities in car sharing. In Paris, there is Peugeot, Renault, Mercedes that is doing car sharing. Everywhere, in Madrid, in Barcelona, there is car sharing everywhere. In Toulouse, there are car sharing also, not developed in the same manner, but there are car sharing. The question for the car maker is to be everywhere, is to be able to be like Uber, VTC. If you look to this, is to have a ride sharing. Ride sharing is to become a player major that will help people like BlaBlaCar. Car sharing is exactly what I was saying. Insurance, we talk about insurance, to minimize the insurance by tracking the vehicle. Rent a car, change the rental car. A rental car should be as simple as saying, I need a car. And the car is arriving to you, and with your smartphone, you open the door and you start the car. And you are not spending 1 hour to a dealer to find a rental car. All this type of things simplifies the life of citizens is today what car makers are trying to do. I want to be frank with you. Many car makers have a lot of difficulties to do it, especially if they are European. In the Nordic part of Europe is more easy than in the south. And the winner is today, I would like to say, the one that could do it in a very large manner. And it is the case in Japan, and it's becoming to be the case in China. In Asia, all these services are very popular, Japan and China. So it's for that reason Toyota Motor, this is a chart extracted from a presentation made recently, 2 years or 3 years ago by Toyota Motor, should understand that Toyota Motor today is number 1 in the world in producing cars. 10 million cars per year, Toyota Motor. So this company understands mobility and has the chance to have a living lab in Japan. So the next step is MaaS. MaaS means mobility as a service. The inventor of MaaS is the company named WIM in Finland, in Helsinki. I put the figure of a lady that you should know, normally, I suppose, Greta. Greta is from Sweden. The Swedish government, like the Finnish government, the Norwegian government, the Denmark government, all the Baltic countries have a spirit of doing the things in the right manner. I would like you to listen to an advert that you can see on the
Vendez vos produits sur Facebook et Instagram lorsque vous démarrez votre boutique en ligne avec Shopify, la plateforme e-commerce.
This is Laura. She used to have a lot of CDs. Now, she has this instead. She also used to have loads of videotapes and DVDs. But now, she has this. She also had a car that she only used for special occasions and sometimes in her work. But now, she has this instead. And this. This is Lucas and his daughters. Lucas could not afford to have a car, which was rather inconvenient sometimes. Now that he has this, they can do this. And it's much smoother to do things like this. This is the Larson family. They used to have 2 cars, to clean and service and look after. And on top of that, finding parking places near the office every day. But now they have this instead. And they've also got this to look after. So what is this? Well, this is a new service that gives you access to all available means of transportation in one single app and with just one bill. Take Lucas, for example. He usually takes the bus to work, but once a week he plays tennis with some old friends. Then he uses a bike between work and the sports arena. Laura is a dedicated biker. She loves to exercise before work, but in winter she prefers the comfort of the train. Sometimes when she visits clients, she needs to use a car. Then, the travel costs can easily be split between private and work-related journeys. And at the Larsens' residence, there are no more nightly calls when Lisa misses the last bus. She can easily get a taxi. Use buses, trams, ferries, trains, and shared bikes or shared cars, and taxi. Combine different ways of traveling. Let the app suggest route and means of transportation, and even sync it with your calendar. You will reduce your costs for traveling. You will be a lot more flexible. And at the same time, you are doing something good for the city and for the environment.
Clear? Extremely clear. Extremely clear. You see that they have banknotes in hand. Oh, yeah. Excuse me, sir. So, they have banknote in hand. They get incentive for using the application. If they don't have any more, any other way to travel, the government and the region, the city is making incentives. Again, also not only this, the city shops are giving incentives. They are considered as citizens which are playing in the right direction for improving, especially when we are talking urban mobility. So, a subject that I work a lot, and it is a very, very difficult subject that journalists document many times in the wrong manner. I call it the highly automated vehicle. The journalists speak about autonomous car. Autonomous car is not something existing. What is existing is autonomous shuttle or people mover, autonomous, or robot taxi. Look how complex is a system that is looking to the environmental surrounding of a car. One large radar, one LiDAR, that means laser type of radar, a pair of camera, short medium range radar, and ultrasonic detection, and around the car you see everything. You remember the horse in the past. The horse was seeing everything. When the cowboy was drunk, he was saying to the horse, go home, and he can sleep. The horse was autonomous. I put here something clear that you have three types of things today which are on the way to be automatized. The people mover, which is to transport people. The robotaxi, also to transport people, but in a different manner, I would like to say, like a taxi, but without driver, and your own vehicle. If you look to these figures, you see that with the dates, nothing is coming soon. Nothing is coming soon. If you look to the exact, why? Because it's sophisticated, so complicated, and so costly. I put the three ingredients today that you can measure the progress. In California, the subsidiary of Alphabet Google, formerly Google, called Waymo, that developed a fleet of Chrysler Pacifica taxi, robot taxi. You know, in America, people are driving smoothly, the roads are very large, there is no complexity, and you can learn all roads by navigation system. So this is today under evaluation in California. Low speed. In Toulouse, the people mover, which is a shuttle with 10 to 12 people, which is operating inside of the hospital, cancer hospital in Toulouse, between the parking and the hospital itself, is taking people and is completely teleoperated. That means that thanks to the 5G communication, someone is checking that everything is running well. And the last one is the first announcement made by Mercedes, that Mercedes has an agreement to go to the level 3 by 2022. This car will be authorized to let the driver not taking the steering wheel and not looking at the road during only travel in special authorized German highway. There is 10,000 kilometers of German highway where this car can be driven without touching the steering wheel and looking at the road. And maximum speed 60 kilometers per hour. And the cost of this car is 100,000 euros. It's not an urban car. It's still not affordable. There is a lot of work to be done to go to the availability. So, now you are students and you are interested to do things. You want to really go to the doing phase, because learning by doing is the only way. I want to be frank with you. The most complicated things that you will have to do is to develop a prototype of a car. This is very complicated. So, teaming with professors, having partners with the industry as sponsor is something that is making you a capacity to really do something in general. And there are good examples. I take good example, one from Barcelona, which is each year participating to the Formula Students competition with different type of cars, eco-driving and racing, and 5 teams are participating to all events in Spain with new autonomous vehicle is in preparation. And INSA is very well known in Europe because they do a lot of different car performing very well. As an example, this one that was in London performing 188 kilometers with only 1 kilowatt, which is something absolutely. So to do a prototype is very complicated. You should have a strong support to do it, but it's possible. And you have the demonstration here with the colleagues. There are some open open hardware concept existing, not too much. There was a lot, and they are step-by-step declining. I know only this one today in Italy, which is a company that is selling a chassis equipped and is bringing the open hardware. So, what I would like to say, you have the project that has been disclosed by Thierry and many opportunities to compete and to learn from the other. Because if you are participating to this challenge, to this student challenge, you are learning a lot. Because if you go to EcoShell Marathon, or if you go to the Formula Student in Barcelona, or if you go to the UTAC challenge of the autonomous vehicle in Paris, or to the Albi Eco Race, which is to optimize the economy of energy, you will find colleagues coming from all Europe. And this is a fantastic way to learn about a different way to do things, and also approach to develop a prototype. So this is for hardware. Of course, for software, you have in your school incubators to develop startups, to develop software in the application using a smartphone, and making the application supporting on the cloud is today more easy than to develop the hardware itself. So I would like to say, if you are really having a great idea, looking to this presentation on a new type of services that could be very helpful in your city, it's something that you can more easily develop in the school you are with, because you have all environment, and in addition, the incubator concept that is helping you. So there is also open source component, more and more available on the net, and this open software source component can be used. I know that Thierry has selected some, for example, for the autonomous vehicle. So you are in Barcelona? Wow, great. You have plenty of doors to knock. Outside of the university, you have the Engineering Society of Engineers of Automotive, you have the Cluster of Automotive that launched a fantastic platform for talent, for young engineers. You have the EIT Urban Mobility that is hosting this project. You have Carnet, which is a cooperative automotive research network. You have SEAT that is a central R&D in Europe for the group Volkswagen in the software for urban mobility services, and more. So Barcelona is a city for ITS, Living Lab, and urban mobility. It's the same in Toulouse, guys. Toulouse Smart City. I am personally representing the Automotive Society of Engineers, but you have also the cluster totem of automotive and transport and the mobility, which is here. Toulouse is member of the City Club of the Urban Mobility. You have in the university the Auto Campus, which is willing to really bring autonomous mobility and services in operation. In Toulouse, there is the Francazal Campus Transport of the Future, where EasyMile, the shuttle, the autonomous shuttle, is located. And of course, you have also the Campus des Métiers, which is something very unique, where you have young students with engineering graduates that are joined together, working on common platform to develop a common concept of a shared, autonomous, electrical vehicle. And last but not least, in Barcelona, you have the SEAT code, but in Toulouse, you have Renault Digital Software Factory headquarters. Mr. Software Digital of Renault is in Toulouse. The boss of Japan, India, everywhere is in Toulouse, and there is a digital software in Toulouse. And Continental, the big German group, has also the digital service organization that is located in Toulouse. So you are in the right cities, Barcelona and Toulouse. If you are not achieving what you are expecting or dreaming, something is wrong. Last but not least, if you want to know better about the new competencies that this industry, which is completely changing everything, in mobility, in new materials, new battery, new energy, new service, everything is changing completely everywhere. You have a book which is called Compétences rares et d'avenir pour l'industrie automobile. Unfortunately, it's only in French. It has to be translated for our colleague in Barcelona. I'm sure that the colleagues in Barcelona will do it. And this white book is available free of charge. You can click and get it. And you have exactly the definition of all the competencies that this industry is willing to have. And we need thousands, you have seen, 10,000 of engineers more everywhere. That means that if you are motivated to change the world, we need you. Thank you so much for attending. Pleasure.
Thank you very much, Jean-Luc, for this talk. I think it's a great talk to introduce all the seminary of the project. So we have some questions from Angel Lopez. I think you know him. The first one is about obsession of car maker to offer a larger battery and ultra fast charging instead of promoting a good use of and rational use of vehicle and energy.
You know, the problem of car makers is their customers. I think that you have seen in China that exactly the contrary is occurring. That Tesla, of course, is selling cars, but the most sold car in China is a small urban car with small battery. So I think the problem is customers that are used to have cars with a range of 600 kilometers are afraid to have a smaller range. And they want to have this range immediately. That means that they want to recharge it so fast in order to be able again to drive. And this is the education that has been made to everybody by Tesla. Tesla has been leading this education of there is no change. You can use an electrical car and you drive exactly the same than in the past with your traditional diesel or gasoline one. So I would like to say customers are the drivers. If young people go more and more by using sharing cars, at urban cars and small cars, and these cars are having a 70-kilometer range, autonomy, and are so cheap to be used. so cheap that with the application, you have seen the MaaS application. It's very affordable because it's very complementary to using bike and scooter. You have seen the range is 70 kilometers, is 10 times the range of a traditional active mobility, walking or using a bicycle. So I'm sure that the car maker want to deliver the best to their customer. The problem is today the customers are not asking the right question to the car maker. So when this right question will raise, the car maker will be very easily serving the demand of such low-range small battery.
Another question about traditional company in car making. Is there a danger for them? Because in fact, electrical cars are simpler to produce. So there is a new actor like Tesla, that become a great actor in automobile. And is there some company like Apple, Intel that can enter and produce some car instead of traditional car maker?
There are different questions. The first one is clearly when you see the success of Tesla today, there is a danger for company because he is reaching the level of volume. Today, Tesla will rise to this year, if there is nothing changing, it will rise something like 1 million cars per year, which is a number of cars that are selling premium car makers in Germany. So he will be at the same level that the premium in Germany. So clearly there is a danger for premium car makers, of course. On the other side, Tesla is not a company that is willing to do something else than attacking the premium. You see, at the moment, if Tesla go down and makes the replacement of the Twingo or the replacement of, I don't know, the Ami in the future, I think today Tesla is attacking premium, clearly. And the premium have really some trouble. If you look to Alphabet, Waymo, on the robotaxi, what are these companies, Apple, Alphabet, Amazon, doing? They go to a car maker and they say, hey, guy, can we cooperate? I will put my software and my platform of human-machine interface in your car. So the car maker is doing a car. The software is, of course, made by these companies. And these companies, why these companies are interesting to have an autonomous car? Because if you have an autonomous car, you sit down on your car and you continue to surf on the Google site, on the Amazon one, etc., etc. So you continue to play additional time on this GAFA. So, but they are not interesting to manufacture and to deliver cars. The value added by a car maker is between 5 to 7%. The value added by the software made by this company and the application that they deliver to the end public is in the range of 30 to 50% or more. So we see that Tesla is a good example. Tesla installed a division for the driving pilot. He don't want to deliver this to Alphabet or to Google. He do it by themselves, and he's selling this software $1,700 per car. Why Volkswagen will employ 10,000 software guys? Because they say perhaps we will do a better integration in the vehicle architecture than the platform made by others. So today I think there is a big question. Yes, there is a possibility of big change in the value chain of the automotive sector. But designing, manufacturing cars is very difficult and is having the necessity of having some specific know-how. So all the GAFA are software-oriented, and they want to save the margin that they have with their application. designing wheels and making a car running is not really what they are interested in. This is my understanding today, but the business model is evaluating rapidly, and perhaps I will be surprised in the next 5 years when we look who is buying whom. You see, 2 years ago, one year ago, Peugeot, Citroën buy Opel, Fiat and Chrysler. Only one group today, the French group Stellantis, is merging 4, 5, 6, 7, 14 brands. 14 brands are within a same car maker. Why? Because you need to reach the 10 million car manufactured by year in order to be competitive in front of the other. So Volkswagen, Toyota, Stellantis, General Motors are competing with level of manufacturing of 10 million cars. It is clearly that if Tesla reaches the level of 1 million, it will start to be disruptive for companies like BMW and others. But in my point of view, there are other car makers that have different volume, and they have also the capacity to deliver cars like urban cars and entry cars to big volume around the world at a competitive price. Tesla is not today affordable for all of us, and the problem here in Europe is affordability of electrical cars. Electrical cars are expensive.
There's some question, could be in French, inside the room. Yes, I think there's some question here.
Okay. So it is an obligation to use software in car, or maybe we can just thinking an easier way to just use a car to drive, or in our century we're forced to use software.
You know, software is something that is capable to optimize behavior. If you remember the story of the vehicle, in the past there was only mechanical parts. A carburetor cannot optimize the consumption of a car. If you take an electrical car, and if you want to optimize the usage of electricity inside of this car, you cannot do it yourself. It's impossible. You have to react to everything inside of the car in a real time. That means microsecond, millisecond. So it is something that only sensors and software and algorithm can play this optimization in real time. So if you want to do the best control and the best approach, at least, for example, on a small electrical car, to manage the battery energy, you need sensors and you need software in order to do it. It's mandatory. It's today mandatory to optimize the behavior. If you let only mechanical components doing the job by themselves, you will not get the optimum efficiency. It's for that reason, when we talk about electrification everywhere, beside electrification, there is a control command. A windmill, a solar panel, if you optimize the inclination of the solar panel, you will be in a position to get more. So today, the question of being back from using electronics and software for control is saying, okay, I will not be optimized. And today, each element you can save in terms of energy has a lot of value, we know. So I don't see the way to bypass the use of control and software in the world because it's, for me, the only way to do things in a very optimized and economy of energy for everything and for everywhere. Is answering to your question? Yes. Okay. So,
moi j'ai une question sur la maintenance. Est-ce qu'il y a des pistes qui sont en cours? Parce qu'en fait, les voitures sont de plus en plus difficiles à réparer. On passe par des circuits secondaires qui rajoutent un prix à la voiture. Donc je voulais juste vous entendre sur ça.
you're right. I'm speaking English for the colleagues in Barcelona. So the question was, is there maintenance of maintaining a car cost? And as much as they are complicating, the cost is rising and becoming less and less affordable for people having a car. So you're right. This is a key question. Renault find partially an answer with refactory. Refactory means the car will have a second life, second hand and second life. The question is repairing. What is today possible to be made in order to repair more efficiently is to improve the diagnostic inside of the car. So this is the first element. So the diagnostic has to be improved. And if it is improved, and if it is sent, for example, through the connectivity media to the car maker, this can be an element to prevent failure. So the idea is to have a preventive maintenance. Instead of going to the car repair when you have a big problem, you are tracking the vehicle and the diagnosis of the vehicle in such a manner that if there is something that is going in the wrong direction, you can ask your customer to come and to make a trimming before there is a catastrophe in the vehicle that will have a lot of cost. This is one element. This is very popular on the truck. When you have a truck going from Moscow to Portugal, 10,000 kilometers on the road, no way you cannot have a catastrophe failure. So the only way to do this is to have, during all the trip, a diagnosis, a complete diagnosis of everything and monitor if everything is going in the right direction. This is one element. I don't see, and the other element is thanks to software again. You can use software and you can reprogram your car using wireless link and internet. The car maker can send a patch to the car and prevent an element that is going on the wrong direction. So block this element, block this sensor, block this part of the software in order that it will not provoke a catastrophe failure. This is also something that is possible today. Tesla is reprogramming all cars in the world, not every day, but very often in the months. They are sending patch of software and they are changing. This is to improve the behavior and not to repair. But this is one way. And also, I think if the concept of refactory of Renault is becoming more and more efficient, it will be also a possibility, as I was explaining, to maintain the car longer. That means to have a retrofit also of technology, or to have a repair made with the support of artificial intelligence. What is appearing today is that some car makers, some repairmen do not know how to repair your car, and they ask you to replace parts which are not faulty. This is also something that, because they don't have the right tool to make the diagnosis, and this is something that is evolving rapidly. And due to the connectivity and to the possibility to communicate between car and the car maker, this is improving days after day. And as it was said, electrical cars are simpler. They have less elements, and normally you don't have to take care of oil, water. All this type of thing has been thrown out from the vehicle. Normally there is a zero maintenance car, an electrical car. Just for your information, is a zero maintenance car because you cannot get failure after a long usage. But you're right, this is something that has room for improvement. I agree.
Good afternoon. Thank you for your presentation, your great presentation. I have two questions. The first one is, what do you think about the online vehicles maintenance? Do you think that with all the technology that we have to date will be able for somebody who drives a car, he would be able to be repaired by car online? This is the first question. And as you were mentioning, everything, all the system is connected. Smart cities, vehicles, What do you think about the stake of the security system, infrastructure system? Does the producer of automobiles and the industry of automotive are working together to improve this security system? Thank you.
So for the first question, I think I have partially answered with your colleague. Is it possible to do everything online? I have some doubt that everything can be made. More and more, yes, but everything, no. There is surely some type of failure that need to be cared by diagnosis in one thing, clearly, of course. Intelligent diagnosis using artificial intelligence on a server by the car maker is an additional element. Prevention of failure and catastrophic failure is also something that is on the way. But replace completely the physical approach, I have some doubt because still we see that there are necessity of some recall. You have seen even Tesla have some recall of cars in order to make a fine-tuning of something that is not fitting with the expectation of durability, robustness, etc. So, improvement, drastical improvement, yes, of all cars, with over-the-air programming and over-the-air diagnosis with artificial intelligence system located on the cloud of the car maker, yes, but everything, no. For the second question was referred to, I don't remember. The problem of cyber security and hacking. This is a problem this is a huge problem. You see each country is suffering attacks. Internet is suffering attacks. Companies are suffering attacks. If you have a connection of your car to internet, the car will suffer attack. So the question is how to prevent attack and jacking from the external. So there is, if you read the book of new competencies which are mandatory in the automotive industry in general, you see cyber security. Cyber security at all kind of elements. So you need to have a firewall, which is an hardware one. You need to have the partitioning of the architecture in such a way that the hacker cannot penetrate inside of the intimate driving of the car, the steering wheel, the braking, the engine. So you need to have a specific firewall to prevent this in order to prevent hacking from the external. So there is a lot of energy spent. Even the car makers are asking to all universities everywhere, and Tesla is doing this very oftenly, to all universities to bring a car and try to hack the car in order to measure the robustness of the technology. You need to improve this robustness day after day. No way. This is a specialty which was not existing in such a manner in the past. Today it's becoming huge. This is a problem of if you have a network of energy with all kind of energy which is network on the same network, for example. If somebody attack the network of renewable energy, he can paralyze energy in a region, in a country. So all companies that are bringing services where there is a possibility of problem for human being and citizen are working hardly to define architecture, software, hardware, mechanics, architecture to prevent hacking. This is a hard job everywhere. And as I say, continuously they're asking to the best university in the world to hack their product in order to be sure that they are robust against hacking. So, of course, if you are networking with internet, a lot of things, you have to be prepared for hacking. And this is something that we cannot accept. So we are working hardly in this industry and all the others to not be to be protected at the right level. This is my answer, and this is a key competence that schools have to bring to their students. Okay.
There's some new question. Have you?
There is an ending date for this conference.
The last one. Any comments on the evolution of on improvement of active and passive safety systems?
Alors, passive safety system, I think, are today quite well developed. Active systems, I would like to say, I show the environmental sensing and I show how the connectivity can improve also by car-to-car communication and car-to infrastructure in addition to the environmental sensing, the active safety. The goal is clearly collision avoidance, zero accident. So today, the improvement exists at medium range speed. You have seen that even Mercedes, with a car which costs a huge amount of money, do not recommend to use the active safety in a standalone manner above 60 km per hour. So we have to be frank, the question of speed versus safety is the key question. If you limit the speed, and it is the case, for example, for Easy Mile on their shuttle, if you limit the speed to 25 km per hour, 30 km per hour, you can do a lot. With high power computing, you can do a lot to escape from collision and to have zero accident and to bring your car in a safe mode in order to escape from the collision. But this is a relation of today, speed, and also when we talk about shape recognition, object recognition, there are plenty of use cases where, frankly speaking, we are not able to distinguish exactly which type of object we have in front of us. And this is something that make still the active safety and the commitment on the paper that the car maker is selling a car and commit zero accident. It's not possible. It's possible only in some areas, and you have seen that Mercedes qualified 13,000 kilometers of highway and not the other. So there are plenty of conditions that have to be put in evidence. So active safety, 100% secure, is not reached today. I want to be frank. Zero accident, zero collision is not reached today. It will take a long time. And today, what is changing completely in our mind is that we can do something somewhere. In the past, when we buy a car, we can do everything everywhere. We can drive in all roads. We can go everywhere. We can drive and do everything everywhere. With the new kind of active safety and zero collision and collision avoidance system for a highly automated car, we cannot do any more this. It's not possible to certify and to sign that we can do everything everywhere. There will be certified roads, certified streets, certified environments where we can guarantee the zero accident, but not everywhere. This is my today assumption.
Okay, thank you. So thank you very much, Jean-Luc, for this presentation. I think we have a very large view of historic of electrical vehicles. We have a view of challenges, and in fact, the car maker change a lot, and there's a lot of opportunities to propose a solution in urban mobility. Thanks again for isdaT to have help us to organize this event, and thanks for multimedia services. The next speak will be on design on urban mobility. So another way to see urban mobility, and this is a talk in Toulouse. And very soon you will have also some other seminary organized, and you can get this information on the website. So thanks again, and see you next time.
the first time in my life, I do conferences everywhere in the world in the automotive industry. The first time in my life, long life, around the world, everywhere, I see so many ladies attending my conference. I am really happy.
Merci. Merci beaucoup.
C'est coupé?
Ça y est, c'est coupé.